Now, for questions 6, 7, and 8, I'm going to show you these three without using the calculator, so we can kind of try to logic our way through them a little bit, and then I will show you guys how to actually use the calculator to get the exact amount that it would be looking for here. Okay, so don't go too far ahead because I want you to kind of think about what we're looking at here. So question 6, what percent of the stopwatch times are less than 4.82 seconds? So 4.82 seconds is right here on my graph. And so I want all the times less than that, which is basically this little blue section right here. Like that's the part that I'm trying to figure out. And so if we want to think about this, right, I'm basically needing to get rid of all of this right side, right? I know the whole thing is basically 100%, right? 99.7 is close to 100%. So I need to get rid of this whole other giant half. Okay, so that means we know, kind of one of the things we can think about is we know from this green, the start of this green bar to this green bar, right, within 2 standard deviations of the mean, that's a total of 95%. And so we know that that part's 95, which just means how much is this extra part, right, that we can kind of get rid of. And so what we're going to do here is we're going to think about, okay, well, if that's the 95%, then the two outsides, right, have to make up the extra 5%, right? Because 100% minus that middle 95% is 5%. But that 5% represents both of these blue ends here, right? And so I only want the one blue end. And so how much is one of those blue ends? Well, it's that remaining 5% cut in half, right? Because there's two ends. So we're going to take 5%. We're going to divide it by 2. And that's going to give us about 2.5%. And there's our answer. And so that 2.5% is one of these little blue sections here. Okay, so one of those makes up about 2.5%. I'm just going to get rid of this, and I'm going to move that down towards that section. Okay. So now, question 7. What proportion of the stopwatch times are between 4.92 and 5.22? So 4.92 is right here, and 5.22 is right here. So we're trying to think about what percentage would be in between that. So I know it's that middle part, right, the pink stuff, plus one of the green sections, right, so half of the green stuff. So we know the middle part is that 68%, right? That was our within 1 standard deviation is about 68%. So we know we're going to have to use 68%. Well, the other thing to think about is we know that this middle section between the two green parts is 95%. So the pink plus both greens gives us 95%. So if I want to find just the green sections, I'm going to take the whole 95% and take out the pink stuff. So we're going to take 95% and subtract 68%, which gives us about 27%. So that means the green stuff combined, right, both of those combined is 27%. So with that, I only need one of them, right? We're going from the 4.92 to 5.22. So I need the pink stuff plus one of these green things. So again, I'm going to have to cut my green stuff in half because I know both of them is 27%. So what is one of them? I'm going to take the 27% and divide by 2, and that gives me 13.5%. So what that tells me is that one of these green wedges is 13.5%. So all of the pink is 68 plus that 13.5 from the green. So 68% plus 13.5% is a total of 81.5%. And lastly, question 8. What stopwatch time is at the 84th percentile of the distribution? So we're trying to think, okay, 84% of the data is less than this number. So if we're thinking about it here, right, we're looking for a spot. Don't just delete all your colors if you've been coloring in with me. But we're looking for a spot, right, that somewhere around like here-ish, right, is our 84%. So let's think about this for a second. So 84%. So actually, I'm going to get rid of these red lines for a second. So where would that be? So something we want to think about is the fact that our mean, right, this mean cuts our data in half. It's right in the center of our data here. So in this case, our mean being in the middle means that this whole left side is 50%. And the whole right side is another 50%. So we know that we have 50% on the entire left side. So this whole, I'm going to do orange here. Go back to my highlighter. So I'm going to color all of this. It's going to be hard to see now, but all of this in orange here. It looks kind of weird and gross. All of that gives me 50% of my data. Okay, that whole left side over here. So that's all 50%. So there's my first 50% of my data. Well, I'm trying to get up to 84%, right? It says the 84th percentile. So where did that other 34% come from? Well, again, let's think about this. We know that 68% of our data was in that middle. And so that means each of those sides, right, one standard deviation on the left, one standard deviation on the right, is half of 68, right? 68 makes up that whole pink set. So if I try to split it in half, I'm going to divide it by 2. So if I divide 68% by 2, that gives me 34%. And so I can know that one of these pink sections, just one from here to here, is 34%. Well, what do you know? 50% on the left plus that first pink section of 34% gives me a total of 84%. So that left 50 plus that 34% from the middle pink section gives me 84%. So where was that 84 percentile? It was at the very end of my pink section here, which is right here at 1 standard deviation, or at 5.12. So the 84th percentile was at 5.12. Okay, so that's kind of how to logically think through where some of these numbers come from. Again, I'm going to show you really quickly how to find that on the calculator. It's kind of nice, it's pretty simple. But it is good to know that, right? To think about these things as, oh, this portion of it is this percentage, and the left side is 50%, the whole thing is 100%. All of that little pieces of information become really useful later on. So how do we do that in a calculator now? Question 6, what percent is less than 4.82? So I'm going to go back to the left, and I'm going to change this graph to be the shading to the left. So you notice now my shade is on the left-hand side of the graph. So I want it less than 4.82, and it shows me about 0.228, 0.0228. So from the calculator, 0.0228, so about 2.3%. So we were pretty close. Okay, and again, we were using approximates for this, so it's good to be pretty close. Question 7, what proportion was between 4.92 and 5.22? We're going to go back to that in-between graph. So I want the shading in between. We're going to go to our left side was 4.92. Our right side was 5.22. And it says 0.8186. 8186. So about 81.9%. Again, pretty darn close. Okay, we were a little bit off, and that's okay. And question 8, what stopwatch is at the 84th percentile? So this one's a little bit different. We weren't given seconds this time. We were given a percentage, right? 84%. So it's a little bit different. I'm going to make sure my graph is on the left-hand side here, because the percentile is everything less than 84%. So instead of typing in a number here with the X like we have been, I'm actually going to go to the right-hand side here. So remember, the right-hand side gives me the percentage, so I can also tell the calculator a percentage. So I'm going to tell it 0.84, because that would be 84%. And it will tell me it needs to be at 5.119 or 5.12, which is what we see here, right? 5.119, which is rounds up to 5.12. Okay, so again, our calculators are really nice, they're really powerful, and can do some of that, but it is still important to kind of know the percentages, to know that the middle of my graph, in between one standard deviation is 68%, out to 2 standard deviations is a total of 95%, and then all the way out to the third standard deviation is 99.7%. And I'm going to kind of quickly try to wrap up with some notes here. I will leave the answers to this lesson app as part of the completed notes document that you can kind of read through or try on your own and then check your answers and kind of see how you did. But I want to leave you with a couple of notes here, and then that way you can have the rest of the time to work on this lesson app and your homework assignment for this section. So first, our big main thing we talked about, our kind of learning target number 1 and number 2, talks about the empirical rule. And so if you remember from the first video, this was the 68, 95, 99.7 rule. So if we draw a normal graph, try to leave myself enough room here. Close enough. So our mean is going to be in the center. So there's our mean. Our first kind of distance away is mean plus 1 standard deviation. And same thing on the left, except now it's minus 1 standard deviation. Our next one out is mean plus 2 standard deviation. And similarly, mean minus 2 standard deviation. And then all the way out here, mean minus 3 standard deviation. And on the right-hand side, mean plus 3 standard deviation. And so what that rule says is within 1 standard deviation on either side is 68% of our data, or about 68% of our data. Between 2 standard deviations of the mean is 95% of our data. And within 3 standard deviations, we have 99.7% of our data. And let me fix that 9, sorry about that, 99.7%. So within 1 standard deviation, within 2 standard deviations, within 3 standard deviations. And again, we kind of briefly talked about this towards the end. This is a normal graph, so we're going to label it with an N, and we always label it with our mean and standard deviation. And then learning target number 3 has to do with assessing normality. Like, how do I tell if a distribution is normal without it telling me? Like, if I'm just given a data set, how can I tell it's normal? So first of all, we want to observe the shape. So we're going to observe the shape of either the dot plot, it could be a histogram, or even a stem plot. So if the shape doesn't really match, right, if it doesn't even look normal, that's kind of our first thing to say, okay, yeah, it's not normal. And then once we kind of have checked the shape and say, okay, yeah, it looks kind of normal, right? It's got that symmetric shape. It looks kind of like a bell. Okay, there's only one peak. Then we need to check if the data fits the empirical rule. And so what I mean by that is I should check and say, okay, I know the mean of my data. I know the standard deviation. If I don't, I can use a calculator to help me figure that out, right? Put it into your NumWorks calculator, calculate it, go look in the statistics and see what the mean and standard deviation are. But then from there, right, I should be able to say, okay, my mean minus 1 standard deviation is blank, and my mean plus 1 standard deviation is blank. And so basically, if I just label these two random letters, right, X and Y, so between X and Y, there should be about 68% of my data, right? Within 1 standard deviation, there should be 68%. So if I look at my data set, like for example, this one, right, I would count how many numbers are in between X and Y, right? 1, 2, 3, 4, 5, 6, and 6 out of my total is about 68%. Okay, I'm just using those as an example. Okay, it's obviously not a direct one, but that's the idea. Okay, is I would check and make sure that that's about 68%. Then I would need to check 2 standard deviations. If I do the mean minus 2 standard deviations, the mean plus 2 standard deviations, I'm going to get a new X and Y. And I'm gonna say, okay, between these two numbers, do I have 95%, right? Because two standard deviations is 95%. And then similarly with three standard deviations, do -3 and +3, and then is that within 99.7%? Is it close? And again, the percentages aren't going to be exact. Okay, sometimes they'll be 69% or 94% or something like that. And if it's fairly close, then yeah, then we're good. But if they're all really far off, if my one standard deviation is 85%, that's probably pretty high. And if my middle two standard deviations is then 100%, then it's not normal, right? Because it's way off on both of those, and it's not gonna be close. Okay, so that's the idea when it's checking for the empirical rule. And so if you want a good example of that, again, um, read through this lesson app. Okay, specifically this question here, question 2. I will show you, I will kind of write in some examples of what that looks like. Okay, assessing normality using the mean plus and minus those different standard deviations. Okay, so that is it for 2.4. If you have any questions, let me know. I can't guarantee I'll respond right away, but I'll respond when I can. But hopefully that gives you kind of an idea of what we're working with here. Okay, so again, the big thing here is that empirical rule, the 68, 95, 99.7, where 68% of the data is within one standard deviation, 95% is within two standard deviations, and 99.7% is within three standard deviations. Hope you guys have a great day. Hopefully this helps. Trying to record this. Sorry if you heard my alarm go off or if you heard the cats jingling around. But I hope you guys have a great day, and I will see you guys soon.